Welcome back everybody. So this is part of the channel where I go through an exam style question. This one is related to integral calculus and the trapezoidal rule. Okay, I'm going to set the timer going in a moment and we're going to do the whole question. It is a 10-mark question, so I should be able to do this in less than 10 minutes. Let's get started. Okay, I'm setting the timer going now. Consider the region R enclosed by this curve. Sketch the curve and shade the region R on the following set of axes. Now I can see that this is a concave down quadratic and it would pass through the axis at 2 and 8. Putting those values in would create a 0, so therefore it will go through that. Now I do know the shape of this, it will be a concave down, but let's say you were unsure about it and you needed to sketch it. I will do that for you quickly now. We're going to go over to the graph, and we're going to sketch this curve. So if we go here, sketch, so it'll be minus 3, open brackets, x minus 2, open brackets again, x minus 8. We press enter, so this is concave down shape. Can't quite see the top. It does say that the y-axis goes just past 25, so I'm just going to put 30. And therefore we have our maximum range. We can see that our domain, which is our horizontal, is correct too. So we're going to go back over to here and we're going to sketch that on the graph. So it's going to go up and have this parabola shape. Okay. Write down an integral that represents the area of region R. So I'm just going to write that on here. That is going to be the area is given by the integral between the lower bound and the upper bound. So that's 2 to 8. Of the function, which is minus 3, x minus 2, x minus 8, okay, with respect to x. And that is the part A and B1 done. Find the area of the region R. Well, that's relatively easy to do as you have a calculator. So the calculator will do all that hard work for you. So I'm going to go back over to the calculator. You can find the bounded area between these two using the analyze graph function, okay? But I'm actually going to do the bring a calculator page up because I know I need it for the next part anyway, and I'm going to go menu, calculus, numerical integration. So our lower boundary is 2, our upper boundary is 8, and our function was minus 3, open brackets, x minus 2, and x minus 8, and that is respect to dx. So there is another way of doing that, and that is find the shaded area between the 2 points. If you want me to do that, I can show you in another video. Press enter. So it was 108 units squared. So if I go over to this one now, find the area bound between, so that was this area here that I'm shading. This is 108 units squared. Estimate the area of the region R using 5 trapezoids. Okay, so this time I'm going to do this on here. So I want to know, so when you've got this shape, we've got these different trapeziums. Okay, we want to know what the width of each trapezium is going to be. Okay, so we do that by doing b minus a over the number of trapeziums that we want. So in this instance, it was 5. So b minus a was going to be 8 minus 2 over 5, so that's 6 over 5. Now if you aren't sure what 6 over 5 is, you can always jump back to the calculator. It's a little bit tricky jumping between screens on the iPad. So we have got 6 divided by 5. Okay, if it comes up as an exact value, remember you can press Control Enter and it'll convert it to a decimal. So it's 1.2. Now that's quite important because we're going to use that in the next section. We are going to bring up, let's go back over to here just to make sure we're all okay with this. The width of each trapezium, okay, is going to be, so let's say this was one of our trapezium, for example, right? The width of this is now going to be 1.2, okay? So if we're starting at 2, the next one will be 3.2, next one will be 4.4, and so on. So we've got to put all of these lines in now. So we're going to go over to the list and spreadsheets section. I'm going to bring up a list and spreadsheets here. So insert a list and spreadsheets, and we're going to start with our x value. So our lower bound of our x value was 2. The next one will be 3.2. Remember, I'm adding 1.2 onto that. Then 4.4, and then 5.6, 6.8, and the last value 8. So you know you've done it right because then there should finish off with the upper boundary. Now we've got y, so this is where we want to put in our function. So we've entered this already a few times. It's -3, open brackets, x minus 2, come outside the brackets, x minus 8, enter, and it asks us for column reference or variable reference. We want variable reference here. Press OK, and we have all our values. So we're going to write these values down. So we have got, now because I'm on an iPad, it's a little bit tricky, so I'm going to try to flip between the two. 0, 17.28, so let's go over to here. Just write these down now for a moment. Okay, so we've got 0, 17.28, 25.29, 92, twice, 17.28 again, so it's symmetrical, and that means the last one probably 0, just double check 0. Okay, absolutely fine. Right, so don't forget what we've done here is these are the x values for 2 and then 3.2 and then 4.4, 5.6, 6.8 and 8. And these corresponding values that we found here, now I probably wouldn't do all this in the exam, I'm just doing this for your reference, is y2, y1, y3, y4 and y5. Now, why is that important? Because I want to put this into the formula. Remember the formula for the trapezium rule was the area, is equal to h times a half, open brackets, y0 plus yn, that's the last value, plus 2 lots of all the other y values, and then close brackets. So I'm actually going to do all of that on the calculator right now. So I'm going to go back over to here. I'm going to bring up a calculator screen again. So here, off we go. So the width of each trapezium is 1.2 multiplied by a half, that's part of the formula, multiplied by, open brackets, now it's our first y value plus our last y value. So this first y value is 0, our last y value is 0, so that is in fact just 0. Now you don't really need to put 0, but I'm just going to remind you, plus 2 lots of all the other values added together or summed together. So it's 17.28 plus, now we've got 2 lots of 25.92, so I'm just going to put 25.92 plus 25.92 to keep this nice and simple, plus 17.28 again, 17.28. And if we press enter here, we're going to get 103.68. So estimate the area of the region R using 5 trapezoids is 100, I just remember 103.68. Is 103.68, so rounded to 3 significant figures would be 104 units squared. Okay, and we can stop the clock. Don't forget to like and subscribe to the channel. When new content drops, you'll be the first to know about it. On the left, click the video for more tutorials. I'll see you next time.